Hi, my name is Natalia White. I am a chemistry teacher. Today we are going to be looking on alkenes. Alright, now your alkenes are identified by the functional group C, double bond C. So that's how you identify your alkenes. Your alkenes are unsaturated. So they are unsaturated, and they are unsaturated because they possess a carbon-carbon double bond. We want to talk about reactions of alkenes. Alkenes undergo what is known as addition reaction. So alkenes are going to participate in addition reaction. Now when we are doing addition, it's 1 plus 1 becomes 2. So basically in addition reaction, we're adding 2 reagents, an alkene and another reagent, and we're going to combine 1 product. Now in this addition reaction, your carbon double bond is going to break. So this double bond right here is going to break. The compound is going to add 1 atom or a group of atoms to one of the carbon in the double bond, and the other carbon in the double bond, another atom or group of atoms will be added across the double bond. So the first addition reaction we want to look on is halogenation. In halogenation reaction, we are adding halogens across the double bond. So halogens are elements or atoms that belong to group 7 of the periodic table. We are going to talk about chlorine today and bromine. If we're adding chlorine across the double bond, when chlorine is added to the double bond, we're adding chlorine atom to one and chlorine atom to another. So let's look. Cl, Cl. So we're adding Cl to one of the carbon in the double bond and Cl to the other carbon in the double bond. So in addition reaction, remember the double bond breaks, and then we're going to add an atom on one of the carbon in the double bond and another atom to the other carbon in the double bond. So in halogenation, if we're using chlorine, we're going to add chlorine to one carbon in the double bond and chlorine to the other carbon in the double bond. Let's use ethene as the example. So we draw ethene, and to ethene we are going to add Cl2 gas in the reaction, and what's going to happen is this double bond here, right here, is going to break. When this double bond breaks, I'm going to draw it back without this double bond, right? So I draw back what I have. So I have C, H, H, single bond, H, H. So now I'm adding chlorine to the carbons that were involved in the double bond. So this is hydrogenation. If it was fluorine, what you would be adding would be Br and Br across the double bond. So whichever halogen it is, you're going to add one of the atom to one carbon in the double bond and the other to the carbon in the other double bond. So there are 2 carbons that makes up the double bond. So each of them you're going to add an halide atom. Next reaction we want to look on is the addition of hydrogen halide across the double bond. When we are adding X, we're adding HX, where X represents the halide, and we have H plus X, which X could be either Cl, I, or Br. So any of those halides we're adding across the double bond. In this scenario, we have ethene. Ethene, across the double bond, we are going to react with an hydrogen halide, more specifically hydrogen chloride. So we are going to break the double bond, and then we're going to add H to one carbon and Cl to the other carbon. So we draw back what is left without the double bond, and then we're going to add H to one of the carbon and Cl. In this scenario, we are moving from an alkene to a halo alkene. So in halogenation, we are moving from alkene to haloalkene. Okay, so we have hydrogenation. In hydrogenation, we see the word hydrogen. So across the double bond, we are going to be adding hydrogen, H2. When we add hydrogen across the double bond, we get H and H. So that's what we're adding across the double bond. We are going to use propene as the example. Propene have 3 carbons, so, and has a double bond. So I'm using propene as the example. And in this addition reaction, again, we are going to break this double bond and we are going to add hydrogen across the double bond. So this is what we have. We draw back what we have left before remove the double bond and draw back what we have left. Then to the double bond, the atoms that were in the double bond, we're adding H and H. So in hydrogenation reaction, we move from a alkene to an alkane. So here we have propene here and we are breaking the double bond and adding more hydrogen across the double bond. And so as a result, we form a alkane. So the condition for hydrogenation is nickel catalyst, 150 degrees Celsius and 5 atmospheres. So the next reaction we want to look at is hydration. When you hear about the word hydration, water should come to mind. So basically in hydration reaction, we are adding water across the double bond. But whenever we're adding water, we are going to add water in the form of H and OH. So whenever we are adding water, we are adding H and OH across the double bond. Stop. To break the double bond, and to one of the carbon in the double bond, we're going to add H, and to the other in the double bond, we're going to add OH. So let's go. In hydration, we're going to break the double bond. When the double bond is broken, H is going to go on one of the carbon with the double bond that had the double bond, and OH is going to go to the other carbon. Right? So in hydration, we need the following condition. Concentrated H3PO4, 300 degrees Celsius and 60 atmospheres. That's the condition. Again, we write back what we have without the double bond. And I did just that. Then we are going to add H to one carbon in the double bond and OH to the other. During a hydration reaction, we move from a alkene. So we're moving from alkene to alcohol. Because of this OH, we have a new functional group, and this is the alcohol functional group, or the alkanol. So the next reaction we're going to be looking at is oxidation. In oxidation, we are going to use a oxidizing agent, which is KMnO4 acidified potassium permanganate. So it's acidified potassium permanganate. In oxidation, this is the reagent that we use. The reagent that we're using is H2O plus a free oxygen. Now remember, when we were adding in hydration, we were adding water, we had OH and H, right? Because this oxygen now goes on this hydrogen, when we see this reaction, when we see this reaction, what we're adding across the double bond is OH and OH. So in this example of oxidation, we have ethene and we're adding water, and O, that's the reagent that we add, and the condition is acidified potassium permanganate. Now in acidified potassium permanganate, what we do is we are breaking the double bond here in the compound, and across the double bond we're going to add OH and OH. And in this time we move from a alkene to a diol. So we're moving from a alkene to a diol. Observation: during this reaction, in an oxidation reaction using potassium permanganate, potassium permanganate is going to turn from purple to colorless. That is going to be the observation that we see. So in this reaction, potassium permanganate is going to be decolorized, so it's going to convert from purple to colorless.